The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.
Hi, welcome to You Have Data, but what are you going to do with it? I'm Evan, a technical curriculum developer here at Google. And in this module, you learn how you can gain insight through data using managed big data services. So far in this Google Cloud Computing Foundations course, you've discussed what cloud computing is, the Google Cloud Platform, and using GCP to build apps. You then explored storage options, the role of APIs, cloud security, networking, and the role GCP can play in automating the creation and management of your GCP resources. In this module, you look at some of the managed services that Google offers to process your big data. The objective of this module is for you to discover a variety of managed big data services in the cloud. The specific learning objectives to achieve this include you being able to discuss big data managed services available in the cloud, describe the use of Cloud Dataproc to run Spark, Hive, Pig, and MapReduce as a managed service, explain the building of extract, transform, and load pipelines using Cloud Dataflow, and discuss BigQuery as a managed data warehouse and analytics engine. This agenda shows the topics that make up the module. The module starts with an introduction to big data managed services in the cloud, before moving on to how big data operations can be leveraged through Cloud Dataproc. You'll then complete 2 labs where you use the GCP console and then the gcloud command line tool to create a Cloud Dataproc cluster and perform various tasks. After the labs, you'll explore the use of Cloud Dataflow to perform extract, transform, and load operations. The next 2 labs provide an opportunity to learn more about Cloud Dataflow. In the first, you'll create a streaming pipeline using a Cloud Dataflow template. And in the second, you'll set up a Python development environment, get the Cloud Dataflow SDK for Python, and run an example pipeline using the GCP console. In the final topic, you learn about the role of BigQuery as a data warehouse. You'll complete the module with a short quiz and a review of the main learning points of the module.
Hello and welcome to the 4th day of 30 days in the cloud campaign. Hope you guys are doing well. And for the new people that are joining here, I'll quickly explain through what exactly 30 days of cloud is. And if you guys are dropping in from the previous events, welcome. So what exactly is the 30 Days of Cloud? So 30 Days of Cloud is a GDSC community event that was introduced by GDSC leads and core teams from all over North America. They gather 16 different chapters from different universities, different colleges, came together and put the series of events for you to help you advance in your cloud learning journey. I'll quickly go through some of the important links which you will need throughout these 30 days. So the Cloud Coach live stream link, this link is useful if you want to watch our live stream events, if you want to get access to the leaderboards in terms of which university is earning most badges and see how you stand up with other colleges and university. And also if you want to access some of our past recordings of events. So the Quick Labs link, this will help you get your hands dirty with the hands-on labs for the different tracks that are within the Google Cloud realm. And the Kumo Space link, this is very useful if you have any questions regarding the labs or getting your Quick Labs profiles set up. So why would you want to participate in this campaign? So if you're looking for a career in Google Cloud, either as a data engineer, data analyst, or data scientist, you should definitely stick around until the end of this lab, because we're going to focus on data, machine learning, and AI within this lab, and we'll be going through the first 3 labs within that track in Google Cloud. But it's also useful if you can stick around through the entire series if you're looking for careers within cloud DevOps, cloud engineering, or cloud network engineering. And we'll cover a lot of different topics such as infrastructure within cloud, uh, network and security within Google Cloud, multi and hybrid cloud infrastructure as well. So here's a brief overview of what exactly each of these courses will contain in terms of the labs. It is also important to note that we are hosting these events as a place for you to get started, and these labs can be completed at your own pace, and you can earn badges, and we'll also help you get set up with your Quick Labs account shortly. So today we will be taking on the data, ML, and AI within Google Cloud, and we will be going through the first 3 labs, which is the quick start for data proc console lab, and then the templates lab as well. If you were here for the past events, you've probably gone through learning how to create your own virtual machine. You've gotten a quick tour around how to use the GCP platform as well. And in case you missed any of those events, you can always join in next week, where we'll be hosting another series of similar events and helping you get through those labs. So Google Cloud Skill Badges will be posted on your Quick Labs accounts as soon as you have all of these labs completed. And you might be wondering, how is this going to help me? So before I get to that, I want to quickly mention that for the data, machine learning, and AI lab, which we're going to be doing today, there are 2 different badges that you can earn: the Perform Foundational Data ML AI task within Google Cloud, and then the Insights from Data with BigQuery. So these badges are a way to keep you motivated, and like I mentioned, all of these are self-paced, so you don't have to stick to the 30 days deadline that this series lasts for. You can do them at your own pace. We're simply here to get you started. But by finishing the required courses within this campaign, you don't only get the foundational experience within Google Cloud, but also it'll open more opportunities for you. So let's say you're looking for applying for jobs with roles such as data analyst. Having some of these Google Cloud uh, badges under your name is going to help you a lot, especially on the Quick Labs profile. And if you're applying for Google, recruiters often usually they notice those little things like that. So I want to quickly talk to you about what exactly the badge is and how do you earn that, right? So a badge is an exclusive digital Google Cloud Skill badge that demonstrates that you're more or less very interested with the Google Cloud technology, and you have we really want to learn some of Google Cloud and how to use it for different applications. And how do you earn that? It's pretty simple. You just stick around for the rest of the 30 days with us, and we'll get you set up, or we'll get you set up today with how to create your Quick Labs account, accessing all the different platforms that we use. And that's pretty much it. So I'll quickly do a quick demo of how to get your Quick Labs page set up. So when you go to the quicklabs.com link, this is probably what you'll be looking at. And all you have to do is click on the sign in button on the top right corner, and you will be presented with a login screen. If you have a Google account already, you can sign in right through your Google ID. If not, you can create an account by clicking on this create account button on the bottom left corner. I already have my Google account, so I'm going to use that. I click on my Google account and it will log me in. And once you log in, this is your home screen. And how do you make your profile public? So all you have to do for that is you click on my account over here on the top right corner, and then you click on public profile, and that's it. So now your profile is public and accessible at this following link, and I'll show you where exactly this will come in handy. So if you go to the cloudcoach.dev link and you hit on register to make sure that your badges and your progress is being tracked for your university on the leaderboard that we have. All you have to do is click on register right here once you go into your home screen. And this will open up a form where you fill in your email ID. And then you pick which school you're from. Just an important note, if you don't see your school over here, you can just click on the other option over here before you proceed. But I did see my school somewhere here. There we go. And I click on next. So over here, this is where you'll use your Quick Labs public profile URL, right? If you have forgotten, or if you're doing this at another time, there's a quick handy little video here which you can watch, which basically goes through the exact same steps which I showed you to make your file public. So I will copy paste my public profile link for Quick Labs under here. And then I will acknowledge the terms and conditions and hit submit. So once you hit submit, you should get a confirmation saying that your response has been recorded and you're done. And how do you view the leaderboard, right? All you have to do is click on the dashboard over here, and then this will load a leaderboard page where you can see the different amounts of badges that have been obtained under each track, the fundamentals, the infrastructure in Google Cloud, networking and security in Google Cloud, and the data, ML, and AI, which our event today is focused on. You can see the different badges for that. You can see all the different schools that are involved, and you can see which school is on top. So this is a nice little way to sort of motivate you further on top of the badges to compete with rival universities and sort of keep that school spirit up. And lastly, I will show you how to use our community space, which is going to be very useful if you have any problems that you encounter within your labs, if you have any problems getting your Quick Labs account set up, or if you just want to network and meet other people from all around the world. So what you probably will see once you once you click on this community space button here, this is also the same link as qmospace.com/cloudcoach. What you'll see is this, and you can log in through multiple ways. I'll pick Google for now. And if you don't have a Gmail ID already, I highly recommend getting one. So then you'll be seeing this screen where you can give access. You can manage your video settings, your microphone settings. You can change your display name, hit join, and you'll be presented with 3 different lobbies. So what these lobbies will be used for is for you to go in and interact with other members with the same mindset of getting the Google Cloud certifications done, getting those badges, and staying on top of those leaderboards. There will be swag associated with leaderboards, so make sure you get those badges. So I will click on lobby number 1 because I already see there's 2 people. And if you ever notice these lobbies are full, all you have to do is just pick another lobby and hang around there until someone shows up. But here I see Madusha. Hey, Madusha, how's it going? I can react to him. I can wave to him. I can do the fire emoji. And I'll show you a few key features here. So at the bottom right, you have your map function, which will show you how to, what different elements there are on the particular lobby that you have joined. So if I go here, there's a little stage where you can stand and maybe talk to people, present with people. Hey, Tuan, how's it going? I can see Tuan's waving at me. There is a little nice video here of the event that I'm hosting right now. I can unmute it, mute it, pause it, open it up on YouTube. There's a lot I can do with it. Right, but yeah, other than that, you can hang around a round table. So for example, let's say I want to talk to Jill Patel over here, right? I'll just hang around here and I'll say, hello, Jill. She'll hopefully turn off he or she will hopefully turn off their mic and start talking, right? But this is an amazing way. So I see Musa is here. Hey, Musa. There we go. Awesome. But that's about it. So that is Kumo Space. And yeah, that's pretty much it. So you should now have an idea of how to get this set up. You should have all the tools with you to get started on your cloud learning journey. And wish you the best, right? And make sure you get those badges because there is a lot of swag associated with it and prize associated with it as well. But now, without further ado, I'd like to pass it off to Caleb Litoro. So Caleb Litoro is based in Washington, D.C., and he founded his first internet startup the year right after Mosaic web browser debuted, while still in 8th grade. And he has spent the last 20 years working to reimagine how we use data to understand the world around us at scales and in ways never before imagined. Just as an example, he's working on a project called the GDELT project, which takes into account all the news media from all over the world, and he can perform some very interesting data analysis on it, which he'll be talking about a little today. He's also one of the Foreign Policy Magazine Top 100 Global Thinkers of 2013 and a 2015 to 2016 Google Developer Expert for the Google Cloud Platform. He's also a senior fellow at the George Washington University Center for Cyber and Homeland Security. So, hello, Caleb.
Hey, great to be here.
Yeah, great to be here.
All
Great
right.
to have you here.
Let's see if I can get my screen to share. Let us see. Share screen and, oh dear, let's see if this works. I spend my day with huge data sets, and I think I'm going to be outsmarted by a PowerPoint. Let's see. All right, can
Screen
you
sharing
see
is
my
often the hardest
slides?
task.
Can you see the slides now?
Yeah, we see it.
Excellent. All right, this is great. Should I go ahead then? Take it
Yeah,
away?
you can get
All
started.
right.
Yeah.
All right. Well, thanks so much for having me. It's great to be here today. So I'm going to talk about the GDELT project today. So the Genome Project is entirely open data. So the idea of this, in 30 minutes, I'm going to take you through a very, very fast-paced kind of look at what we do. And remember, everything you see here is open data. So you can go to the Genome Project website, which actually I should have put the URL up here. It's gdeltproject.org. And from that, you'll be able to download everything that you see here, you'll be able to download. And the idea here is to kind of inspire you to say, let's say that you're interested in, well, what would it look like to use video AI to annotate huge numbers of videos, or speech API to understand speech, or the NLP API to understand the entities of a huge amount of text. You can do all that and much, much more. Now, the image you're seeing here, this really sort of summarizes the GDELT project, which is this idea of what would happen if we could scoop up the world's information and essentially use the power of the cloud to take the world's news media in real time and catalog what's happening around the world. And so it's all based on GCP. So everything you see, the primary service we use is Compute Engine. So basically everything runs on a set of VMs within Compute Engine. Obviously, all the storage tools that are there. One of the interesting things is, one of the really amazing things, again, I have a long heritage in the traditional supercomputing world. One of the amazing things about the cloud is we run distributed. I think we run on 16 of the GCP regions now. And what's so fascinating about it is, so we use cloud storage, but we use the multi-region cloud storage as our primary storage backbone for sort of our main data sets. And what's amazing is, any of our virtual machines anywhere in the world can access this shared storage space. And yes, there is a slight delay. Something in Tokyo accessing something that's just been written, say, from a machine in New York, in say Virginia data center. It's a little, obviously there's delays. There's speed of light delays and others. But otherwise, I mean, it's the same environment. A VM can spin up anywhere in the GCP world, in the GCE world, and it sees the exact same environment. It can access storage exactly the same. From the standpoint of the software itself, it doesn't care where it is around the world. And that's very, very powerful for us, obviously from the standpoint of reliability, redundancy, but also our ability to scale around the world. So if some major news event breaks somewhere and there's all kinds of news coming in that region, we can move more crawlers towards that region to ingest it faster. We can, for example, let's say we're experimenting. We want to use some new bleeding edge GPU that's just been released that's only available in one zone. We can go ahead and spin up the VMs to leverage that in that zone. And again, as far as the rest of the infrastructure is cares. They're all in the same thing. So I just wanted to emphasize the fact that, we talk about GCP regions and geography, and that is important, obviously, for a lot of things like latency sensitive things. But in the general case, I mean, the fact that all these regions, some have different processors, some have different GPUs, but other than that, it's the same environment that you can really build these globally distributed infrastructures. And then, of course, the process material we use, all of the AI APIs within GCP right now, and then BigQuery to us is the glue that glues it all together. Absolutely everything. You can imagine we have this huge fire hose of data coming in. So we run essentially a global crawler fleet across the world. We've got a lot of other partnerships. All this data flows in. It all flows directly to GCS. The cloud storage, we then have our compute engine instances that process that, route things to different AI APIs and back. And then BigQuery is kind of the big place that we do all of our analysis. And BigQuery is very, to me, it's very much a paradigm shifting way of working with data, in that BigQuery, you can essentially point at your data and you can go at petabytes. I think you can, if I remember, or at least a couple of years ago, you could table scan a petabyte every 4 minutes. And I'm sure that's much, much faster now. But you don't think about like traditional databases where you need indexes. You have to think ahead of time. How is my data going to be used? And as new use cases emerge, you have to think about restructuring the table or adding indexes. With BigQuery, you don't. You just literally brute force your way through the data. And that's incredibly powerful that I don't have to think. And for example, in some cases, we'll just load in, hundreds of terabytes of JSON data and extract out something that we need from that and just do it in real time. Like it's a fundamentally, it's a really interesting, I mean, how to put it? It really changes how you think about data, that you stop in this environment. Like, I don't spend my days thinking about how many cores or this or that. I just focus on what I want to accomplish. And that's a really interesting thing in the cloud. For those that are maybe have backgrounds in sort of traditional computing, it's a really fascinating trend. So, again, to this idea of taking the world's news media and processing that and turning it into graphs like this. So this is actually a real graph. So in 2013, we extracted out all the person names mentioned in worldwide news in a given period of time and constructed a co-occurrence graph of how they were all related. And you can actually zoom into this and see how, world leaders, business leaders, all these different things all fit together. So on a given day, again, GDELD is our goal is to try to scoop up the world's news media. So this is an actual map of all the locations that we have news from or about within, I think, a 1 year period. Now, again, this just tells you where we're getting it from. But of course, obviously, the world speaks many, many languages. So one of the things that we do is we actually, since 2015, actually machine translate everything that we see in about 65 languages, soon to be a lot more than that. And there's actually an interesting story behind this. In the aftermath of the Ebola outbreak, in 2014, we actually went back, and it turns out we had actually gotten the early glimmers of it through local broadcast partners, but it was in French, so we weren't able to translate it. So this led us to stand up in late 2014, this massive machine translation infrastructure. Fast forward to December 30th, 2019, we actually picked up this surge in local coverage in Wuhan in Chinese about this. It was at the time it was called a SARS-like viral pneumonia of unknown origin. And that was actually used by a company in Canada called Blue Dot to actually send out their biosurveillance firm the following morning after their human. So we basically, they essentially take our data sets, have built their own machine learning algorithms on top of that, flagged that there was this surge in discussion of an infectious disease, sent it to people, and then the following day, December 31st, 2019, sent out a worldwide alert about a coming pandemic. So it's a very powerful thing to say that, back in 2014, we had all this data about this coming epidemic, that we lacked the machine translation infrastructure, that we put that in place, and we were able to send out, Blue Dot was able to use our data to send out that alert. So again, this power of looking across the world. And this actually just shows an example. So this was Yemen a couple of years ago. And you can see blue is what you saw in the English language press. Red is what you saw in the Arabic language press. So again, just reminding us that, so much, and this I think is very interesting, in that historically, a lot of machine learning work has just been in English. But today we have the ability. I mean, most of Google's, so as I'll talk about in a minute, OCR, I think it's 300 some languages now. Speech detection continues to expand. All these tools like, these GCP AI APIs are very strongly multilingual and getting more multilingual every day. So we're not limited to how we used to be. So, think about GDELD. So we're scooping up the world's news media each day. We're translating it. What can we do with it? So we can do things like we can map physical events. We can map narratives and emotions. We can map world events in real time. And this is actually looking at, so literally just taking a news report reports that something's occurring right here. We see that within minutes, that becomes an entry in our database. And in turn, that becomes an entry in a map and so on and elsewhere. Now, of course, oftentimes physical events aren't what you're interested in. You're interested in the narratives behind them. Like if you're interested in global conflict, by the time tanks are rolling through the streets, it's kind of it's game over. What you want to understand is how people are kind of reacting to things around the world, and so you can map narratives. Simply something as simple as co-occurrence mapping. You can do so much with that. Taking any topic and looking at this. And I should add that the graphs, these co-occurrence graphs, we actually use BigQuery for this. We've actually constructed a 1 trillion edge graph inside of BigQuery. Again, just a simple SQL statement. And we don't think about BigQuery as because typically you can't do graph analysis in an SQL database. You can in BigQuery, and so you can just say, look, here's a big pile of data. Basically construct a co-occurrence graph and extract out the strongest links, and then condense that down, output that. You can even construct an SQL query that will output a dot file for Gephi. So literally, you can start with this huge pile of data, generate a co-occurrence graph, and then output a file you can load directly into Gephi to visualize it. And that's a real game changer. We can look at global happiness, emotions. And this is very interesting because what we can do is, again, we're looking at media. So again, this isn't where people are happy or sad. This is how the world's news media is portraying the world around us. And that's a really powerful thing to look at the lens through which we see the world around us. Nowcasting and forecasting around the world. We can look at economic impact, so we can see, how tone and sentiment and the things that people are focusing on actually correlate really, really strongly with the real world. We can map out world events and how they're being covered in the media. We can go beyond, we talk about sentiment. We usually talk about positive, negative, and we actually look at thousands of emotions, things like anxiety. So some things, it's not necessarily positive or negative, but people are anxious about it. So again, remembering that. We can trace out the mathematical equations that govern the media and society itself. Again, when you have data of this magnitude, using things like BigQuery, you can actually extract out these high-level patterns there. Now, how do we do all this? So again, GDAL is used today for everything from measuring risk to looking for disease, to tracking wildlife crime, to looking at future famine, to look at, human rights, catalog human rights violations. I mean, it's used for just anything you can imagine. Now, how do we do that? So again, what we do is we want to take that fire hose of news that's arriving every day and translate that to data. So I'm just going to go, GDAL is an enormous assemblage, all of this open data. I'm just going to go through a few of these today. So one is the quotations graph. So what we do is every day, we go through every minute, 152 languages, and we extract out any quoted statement that's there. And again, so you can go through this and you can take a topic and you can say, what are people saying about that around the world? And this becomes very powerful for things like fact checking. So this gets used by fact checking, misinformation groups to say, well, what are public statements that are being said about? So let's say someone says, so-and-so just acknowledged, just admitted to such and such, be able to go back and say, well, what was the actual statement that was made? We can look at geography. So we can do things like, so we run geocoding across all this. So every news article, we extract out all the geographic statements there. So we can look at what topics, what words, what entities are associated with each of those geographic locations. You can actually make a map of something, even a simple word like the word blue or the word green. Where are they associated? This is actually obviously a map of Merkel. And you can see, what are the locations that the news media most commonly associates with her. We can look at things. So this was actually done. To support some government stuff with respect to the early days of COVID. So you see here, what you can see here is blue is news media coverage talking about quarantines in California. Again, this is early last year. Orange are Google searches from Google Trends data. So what you see is the news media is really putting this out here. People weren't, until it actually. So the news media was saying, look, quarantines are coming, the following things are happening. And this tells you that people weren't really paying attention. It wasn't until, oh my goodness, something's happening, that now we see the search behavior. So again, it kind of tells us, we can start measuring some of that of, well, in this particular case, it was obvious that the government communication through the news media wasn't necessarily having the intended effect of people being aware of what was going to happen. We have a whole bunch of different APIs. You can keyword search, machine translation. So you can say, tell me anything about some, for example, an endangered salamander. What's being said about this around the world? What about ivory poaching? What about disease outbreaks? So you can search across the world's languages. Again, we're machine translating all this. You can search in English across all those machine translations, locate matching coverage from that. We also do television. So we also run an Elasticsearch cluster in GCE. So this is actually a collaboration with the Internet Archive's Television News Archive. We're in collaboration with them. We actually take live television from them. We have an Elasticsearch cluster to search the closed captioning, also the speech recognition, and then a whole bunch of other stuff that I'm going to come to in a minute. So you can do all kinds of really interesting graphs about it. We have the global knowledge graph. So this is a case where we take online news, we codify all kinds of different stuff there. We have a difference graph for those that are interested in information science. We have a difference graph. So that's where every news article around the world, we recrawl it after a day and after a week and actually catalog all the changes there. So you can actually look at how the news is being rewritten. Now the entity graph. So this is actually powered by the GCP NLP API, which is in 11 languages now. And we basically feed a random sample of about 100,000 articles a day through that. And we extract out all the entities. So you can actually basically get this live list of entities there. And you can do really interesting things. So there's another GCP API called the Inference Api. And the Inference API, I believe it's beta now. It's an API, a GCP API, where we can load huge data sets in there and say, so you can, for example, run a search over that data and say, what is statistically significant about this period? So you can do a period of time, particular day, or you could say, like, for example, Elon Musk. You could say, what are the locations that are mentioned more with Elon Musk than with anyone else? So you can see, like, for example, Mars is now more closely associated with him than it is with NASA now in the news media. So again, you can see these fascinating trends there. We also, of course, run it through the NLP API also has dependency trees. So you can do really interesting things like question and answers from that. You can do narrative assessment. So this is the question where we want to ask, has climate change contributed to Australian wildfires a few years ago? And we're able to use the dependency parsers to show that even, for example, the BBC had 3 different narratives there. So even really interesting for those of you that are interested in linguistics or communications, narrative assessments. Again, all this becomes possible with all of that data. Now, of course, where AI really shines is in the visual world. So one of the things that we've done since 2016, we've run more than 500 million images through Cloud Vision, which is Google's image AI. And we extract out labels. So we ask it for any objects and activities in there. We ask it to do OCR. We ask if it can estimate the location. We also separately do EXIF metadata extraction for that and image search. So this is actually an interesting one in that, in this particular case, so again, the Vision API does not do facial recognition in the general case. But what it does do is it analyzes the entities, the captions that are associated with those. So you can say, for example, find me images whose captions, so using web entities, whose captions tend to refer to this entity. And so you can get, for example, Donald Trump. And this is a really powerful way of getting at some of these things without some of those, worrying about things like that. So you can say, for example, give me images that are captioned like this. Here's a flooding example. So this is a real-time tracker of flooding around the world. We can do really interesting things. Remember, I talked about graph construction in BigQuery. So this is a sample code in BigQuery. Again, it's a fair amount of code there, but it's just because, again, SQL is very verbose. But this query essentially says, pull out all the entities that you see in those images and basically build me a co-occurrence graph of what entities co-occur with each other. And so we can build graphs like this and actually dive in and actually understand the landscape of visual imagery of the news media and how the news media frames different things. And it becomes very, very interesting because you get to see a lot of this, like, for example, public transportation, because very interesting. You see like what a bus looks like around the world. But you can also do interesting things. Like you can see, for example, public figures in some parts of the world, public figures like elected officials stand in front of the cameras. In some parts of the world, they always have a podium there. In some parts of the world, they're flanked. So you can start getting at some of these interesting questions about how is the news told in terms of sort of the visual landscape there. Now, of course, television is a huge, interesting area. So in collaboration with the Internet Archive's Television News Archive, we've been running CNN, MSNBC, Fox News, BBC News, and the 3 evening news broadcasts, ABC, CBS, NBC, through Cloud Video each day. And you can actually download those annotation files to do really interesting analyses over the news. And I want to add, so automatic speech recognition. So one of the things that we do, so television news has humans live capturing them, but we also run them through Google's, so the video API supports speech to text. It's really interesting. So we've done a lot of deep assessment. We've actually done a whole analysis actually that has a lot of statistics on this. But we want to compare how does the machine ASR, so speech recognition from cloud video. Now again, this is using the English language video model, which is a very high-end model from cloud video. How does that compare against having the live humans typing it? It turns out the machine actually beats the humans, and that's because television news is typed live. There's literally a human being watching CNN as you watch it, frantically typing on a keyboard, which means that if, for example, there's a name that they're not familiar with on the screen, they might mistype it or just not type it. If they say, this is so-and-so, the former ambassador of the US to Estonia, they might not type the whole thing. They might just say so-and-so, period. Let's say that someone's talking very fast or very technical. Let's say it's a clip from Congress and they're using all this technical terminology. The humans oftentimes will give up. The machine actually just plows through it all. And again, it's not perfect, but it actually beats real-time human transcription. This is a huge game changer now. Again, we've only tested this English so far, but we have confirmed that it is as good as real-time human transcription now. Again, that's not to say it's perfect. It definitely makes mistakes, but so do human beings if you have them sitting there typing in real time. And you can do all kinds of interesting things. And I want to point out, for those that are really interested in this space, search for Google AI Workshop. So Google actually has this amazing thing called AI Workshop, where you can actually sign up. They list all these different experiments, all things that are currently from Google research. They're in experimental stage. So they're things that might eventually make their way into Google Cloud or might not. But you can see they've got everything from image labeling, video labeling, anything you can imagine. They've got all these experiments. You can sign up for one. There's a process. And then if you get access to it, then you're actually getting access to really fundamentally early research. And oftentimes there's you get to interact with a Google researcher behind the scenes. So I highly recommend searching for Google's AI Workshop. One of the ones that we've used a lot, Semantic Similarity for natural language. We've been using that a lot. So that's actually its entailment. It's essentially semantic entailment. But it's wrapped up in an API, and you get bleeding edge models, and you're constantly experimenting with it. And so it's really a way that you can sort of experiment with some of these things, and B, provide feedback that can help shape some of these things. Now with video, we can do all kinds of interesting things. You can look for, find me things that have one person, find me things that have podiums, find me things that have flags in the back. This is actually in the bottom right there, you see bookcases. One of the things that we did early in the pandemic is we used BigQuery and we said, what is statistically different about television news in the COVID era than the pre-COVID era? The very first output that came out was bookcases. Before COVID, bookcases were not to be seen on television news. Post-COVID, bookcases, because everyone's filming from home, and for whatever reason, everyone decided bookcases were where they wanted to be. So absolutely everywhere on television news, there were bookcases. But that's a really powerful thing for those that study the media. It's a really powerful thing to see. And again, that that using this annotation data, you can sift out these patterns. OCR is amazing. So video OCR. So the video API supports OCR. I believe in 300 languages. But you can do amazing things. So you can do just absolutely incredible things. So in the upper right, for example, you can see there you can see that hold on if I can get the highlighter. So you can see up here, this is a motion. So there was something that was scrolling in and it broke up. But again, it saw that should be no more cars because it saw before and after and put it together. You can see computer generated text. You can see just, green text on a yellow texture background with red. I mean, this is a few years ago, this would have been a reCAPTCHA image. And the OCR just pulls it up. But even here, this is an interesting one. So this is actually Urdu language material that was on an ABC broadcast. And it just picked it right up and transcribed it right in the middle of that broadcast. And that's really powerful to be able to do that. Then we can do interesting things. So we can then take that OCR. So you can literally keyword search using that OCR, the on-screen text of television news broadcasts. So like this is a case where we were actually tracking how many seconds a day CNN's COVID dashboard would show up. You can do really interesting things. So this was the case where we're interested in tweets and how tweets are showed up on television news. So we use, in this case, Trump's tweets, and we just look for a Twitter handle. So we literally keyword search television news for a Twitter handle, and we're able to actually track this in real time. Another one, again, just a simple regular expression here. We can say, find me any, so when someone's interviewed on television news, you see their name, their title, and their affiliation. So we said, what medical doctors are being interviewed on television news? And is everybody going for the same ones? Are we seeing different doctors? Are they epidemiologists? Are they immunologists? And so we simply said, find me any DR period space and then a person name. And so immediately then we were able to get all the doctors that were being interviewed on television news. And most importantly, we could kind of see the ebbs and flows that all of a sudden there's a bunch of doctors being interviewed. Now they're not interviewing doctors anymore. That tells us now they're back, now they're not. So you can do a lot of interesting things. So this was a question we worked there was a lot of interest in this in terms of who is telling the COVID story. This is one for masks. So we asked, find me all the imagery of masks and where are we seeing those around the world? We can do interesting things. So this is this is Google Earth. Where is Google Earth used? And you can ask interesting questions. What parts of the world is Google Earth used? So like if they mention Chicago, if CNN mentions Chicago, they don't use Google Earth to show you where is Chicago on a map. But what cities do they use it to indicate where that is? So that we can do interesting things. So this was the case in COVID. So again, remember Cloud Vision that's the image recognition API that has something called web entities. And what that is it's a reverse image search. You hand it an image, it does a reverse image search across the open web, and it says, here are exact matches, here are clipped matches, so a portion of your image, and then here are similar matches. Here are the URLs that I found for all those, and here are the top topics that are most associated, usually in the caption. So essentially, it looks at the caption. Everywhere it found that image in the web, it looks at the caption, where are the topics associated with that? So here was a case where this was a CNN broadcast with someone in a hospital, and it just had it, and there was nothing. And so we were able to actually run a reverse image search and actually get the Yandex source video where this came from with a complete description of where this video was, who it was portraying, all that detail. So we just go from a random clip to all this index behind it. We actually did a case where we took an entire CNN broadcast second by second for each frame, traced it out across where all that imagery came from across the web. So you can do all kinds of really interesting things. So this is a case, this was a still image from that CNN broadcast. And again, it's just an image. There was no credit line. It was just, here's an image in the CNN broadcast. And instantly then from this, this is a fully automated workflow. In one side goes the video. We just took that video, used FFmpeg to do 1 second per 1 frame per second snapshots, ran each of those through Cloud Vision, got all the URLs that match, look at the labels associated with them, then crawled each of those images, scanned them for EXIF metadata, and ended up with this. And then we can do really interesting things. So the Media Data Research Consortium, so that's, again, a collaboration with the Internet Archive. So there, we have so many different data sets that are available for academic research. So we got, radio stations. So the Internet Archive's radio news archive, actually much more than 2.5 million. It's almost 550 stations. Again, not all of them for all time periods. Again, engrams based on that, all kinds of different data sets there. We've got television, we've got web. We have actually a bunch of different periods for television news with different disease outbreaks, because we're very interested in looking at how, for example, COVID was presented to the world versus others. Another area we're looking at right now is the relationship graph. So ultimately, the holy grail for news analysis to be able to take a news article, annotate that to the actual. So today, when you ask, for example, a smart speaker about something, what it's doing essentially is a semantic similarity or entailment match. It's not actually understanding what's there per se, although there is some. If it's in the Google Knowledge Graph, but if it's just an arbitrary question, it's sort of just matching text. What we want to get to is kind of that idea where it actually would understand the underlying text. So we're doing a lot of work with that. We're actually, right now, we have something. We're using dependency parse trees from the Natural Language API. We also are doing n-grams around verbs there. So we have a whole set of data sets there. Obviously, embeddings are very important today. Everyone's talking about embeddings today. So for those that are interested in experimenting with embeddings, we do have, or you're interested in embedding search. So there's a whole area of research right now around embeddings. For those that are not as familiar, embedding essentially is a vector representation of text. So we actually compute document level embeddings, which are pretty rare. Usually you get sentence embeddings. We use the Universal Sentence Encoder v4, which is an open model made available by Google. Just go to the TF Hub, TensorFlow Hub. You can download it. We actually on our blog show step by step how to do it. You can actually do it in a Jupyter Notebook using their setup. So you can actually do this entirely within Colab. So you don't have to, you don't have to spin up a VM. And actually, it's really neat because you can actually use one of the VMs right there and basically follow this stuff and actually do it straight from your browser. Nothing necessary. And what you can do then is essentially you put in your text, you get that nice 512 dimension vector. We generate these document level for, I think, I forgot how many, maybe 500 million articles now. And so you can actually then compare that against news coverage, and we do it across 65 languages. So you can do really interesting things. This is actually an example for television news. We were interested in tracking. So there was that false statement that COVID vaccines contained a microchip in them. And so we were interested, where was this showing up? So we started with that. So we just literally copy and pasted from a factcheck.org fact check this statement. And you can see it up there, a video circulating on social media falsely claims. So we literally took this paragraph of text, computed the USC vector for that, and then just brute force ran cosine similarities of that against every other sentence on television news over a period of time, and then surfaced the most common one. So you can see that these are very similar. What's interesting, though, is this right here, nanochip. So here's a statement that talked about a nanochip in the vaccine. And again, with embeddings, it knows that in this context, a nanochip is probably the same thing as a microchip, and so knew to connect those. So for those that are interested in experimenting with embeddings at scale, or for those of you that are more interested in like the technical questions. So for example, obviously it's not scalable to compute billions and billions of cosine similarities. So there's a whole field of research on optimized, basically embedding search. So there's actually a whole area there. So if you're interested in a large data set of real world data tests, you can use this. And here's actually really cool. So this is something called a TF projector. So this is Tensorflow Projectors, and basically an open website that Google produced where you can upload embedding data sets and visualize them. So here, this is actually, we have a demo around this where you can use our embeddings data set, keyword search for something. So in this particular case, we said, find in a given 1 day period, find all the articles that mention COVID-19 and vaccines, compile that list of URLs, then go to our embeddings table, pull all the embeddings for those and cluster. So imagine you want to look at what are people saying about vaccines today. So you've got this huge pile of articles. What do you do? Well, traditionally you might do something like LDA, latent topic, LDA, but that's, or maybe some form of traditional clustering, but that tends to get these odd clusters that don't necessarily make sense. So what you do here is you just search for the matching articles, go to the embeddings, pull out those embeddings, and just basically view them in the TensorFlow. And so that this has things like TSNE or UMAP or the different embeddings clusterings. And instantly then you can see these natural clusters here, and you can see different languages here. And again, just this ability to take this huge amount of text and bring it on down. And then finally, I want to talk about, there's another tool called Gcp Time Series Api. So that's a new API. I believe it's it's public alpha right now. But this allows you to take huge time series data sets and pull out subtle patterns from them. And I want to leave with this because it's really neat. So this is actually a real map. This is a real timeline of all the covers that we saw mentioning pneumonia associated with Wuhan in December 30th. So what you can see right here is this is 10 p.m. Right here at Eastern time on December 30th. And you can see, we see this huge surge. And then, of course, it goes viral. But right here, Time Series API was able to detect that and basically flag that there's something here. So one of the things that we're working on now is we're actually working, hopefully in the coming weeks, to deploy this for television so that, for example, we are in real time detect breaking news stories there. Now, I know I've gone through a huge amount of material really, really fast. So I'm sure many of you, you're either really excited or your eyes are glazed over at this hour. But hopefully this has inspired you. Again, all these data sets are open. So if you want to see what does the NLP API look like on a huge amount of text, you can go right now, look at our entities data set, and you can get all those entities extracted from that. Let's say you're interested in the Google Knowledge Graph and how Google kind of organizes things. The NLP API, every one of those entities is cross-referenced into the Google Knowledge Graph. So you can see all those entities and see how they're all interrelated. And you can use that to see how different things are connected. You're interested in imagery. Let's say you want to know, I want to build an image visualizer or maybe image clustering system. You can use that. Let's say you want to look at OCR. What would a visual search engine look like? You can do that. Let's say that you want to look at video and you're very interested in what does video AI look like? Well, you can access all those things. So evening news broadcast back a decade, the big 3 or big 4 back to the start of last year. Again, all that's open. You can download all that JSON data right now. Everything's downloadable. It's also all available in BigQuery. It's one of the BigQuery public data sets. And again, if you go to the blog, so just go to the gdoproject.org, go to our blog, and you'll see just copious examples there from BigQuery, scripts, anything you want. showing just how you can ask these really, really fascinating questions from this. So again, I know I've gotten through a whole lot really, really fast, but hopefully I've inspired you and really gotten you excited to go look at all this new open data. So thank you so much for having me.
Thanks a lot, Caleb. That was a lot, and it's amazing, sort of the types of data analysis you can do and like pick up on patterns before pretty much anyone can even start noticing it. And at the scale of which this works is just really impressive for me. I do want to mention, guys, if you have any questions for Caleb, you can always head over to Kumo Space, where Caleb is going to join there in a bit and hang around there for a few minutes if you guys have any questions. Thanks a lot for coming out, Caleb. Really enjoyed that. And yeah, feel free to connect with Caleb on Kuma Space.
Yeah, I'll be there for about 10, 15 minutes. And, again, if you have questions later on, just go to the GDALT website. My email's there, and always happy to talk with folks.
Yeah, that was indeed next level stuff. Yeah, but we will now be moving forward to the next part. See you, Caleb. Thanks a lot for coming out.
Thanks.
We'll be moving forward to the next part of our event, and we'll be running through the labs for the Data ML and AI in Google Cloud track. And I'd like to welcome Hamza on stage, who's our tech lead at Carleton JDSC. He'll be helping you go through this lab. Hi, Hamza. How's it going?
Hi, everyone. Hi, Saurabh. Nice to meet you all. Yeah, so we'll be running through Quick Labs, which just allows you to experiment with GCP technologies. Today, we'll be looking at the technologies that are offered to deal with data in like a free way. So obviously, most of these are paid technologies, so we can experiment with them with Quick Labs for free and learn about them through sort of these labs. So I'll share my screen and we can start looking at these. Just give me one sec. Okay. Is everyone able to see my screen? Saurabh, could I get a thumbs up if you're able to see my screen? Cool. Okay. Is it big enough? Like maybe if I zoom in, is this better? Just want to make sure.
Yeah, maybe just a little bit more would be nice, I think. Yeah, that's good, I think.
All right, cool. Okay, so if we head on over to Quick Labs, there's a link here. Let me just check it out. So if we head on over to quicklabs.com, we log in and then we register for the for this Google Cloud Computing course. You'd be brought to this page where we'll be going through the labs. There's some videos here and some reading that you can do, and then there's labs that sort of follow through with that to get you to play around with like an actual play around in GCP with the real tools themselves. So to get started, we'll go with Dataproc and we'll look into console. But before I do that, does anyone have any questions, or maybe they want me to like show something how to get here? Let me know in the chat and I'm happy to answer them. I'll just wait a few seconds. Okay. At any time, if there's something that I do that you don't understand or you have any questions, just drop them in the chat and I'll pause and explain something or answer the question or maybe go over a step that wasn't clear. So feel free to just stop me and ask questions. We also have other members in the chat that will be able to answer some of your questions. So yeah, ask questions anytime you want. Okay, so we'll get started with this, this lab. So first of all, how to navigate this. In the center here, there's some requirements. There's some setup instructions. Make sure to read these. They'll tell you about like if you have different devices, how to use this lab. They'll tell you about like how to log into these labs and sort of how they work. They're really helpful. So for each lab, you'll be given a temporary Google account to use. and you have to use this account because this is the account you'll be able to use on GCP to sign in and use services for free for a set amount of time. If you use your own account, you do risk incurring fees. So make sure you use the account that will be given to you when you hit Start Lab. When you do start a lab, I recommend, this was just personally for me, I found it best to just open up an incognito tab and open the link there. That way I didn't have any issues with accidentally automatically signing in to like a previous account that I had signed in on to use GCP or anything like that. Yeah, so I'll run through this. So I'll run through this. The other thing is these are timed for 30 minutes. That's just because they are spinning up resources for 30 minutes because they're free. After that, you'll have to start it again if you didn't manage to finish. But most of these, like I did this lab, for example, it only took me like 10 to 15 minutes, I would say. So 30 minutes is like more than enough. So don't worry. It's not like you're in a test and you have to cramp everything in 30 minutes. Okay, so let's get started with this lab. So I'll go ahead and start this lab. Yeah, so you do have some credits when you sign in. I believe you have 9 credits. So you can use those to start the lab for free. So I'll just use one of my credits and I'll just use the subscription. And it should get started. There we go. Once it starts, the timer will start. This is the button we'll want to click, open Google Console to actually open up the lab. I'll just go ahead and copy the link and then open up an incognito tab and put it in here. I felt like that gave me the least amount of problems. I'll then go ahead and copy the username. Whoops, let me just go back to here. So I'll paste the username in here and then I'll take the password. I'll throw the password in here. That should bring me to the GCP console right here. And I'll zoom in, don't worry. We'll need to accept the terms of service. You don't need to do the email updates. It's a temporary account anyway. I'll zoom in a little. There we go. Hopefully that's good to see. If not, just ask in the chat and I'll zoom in some more. So the first thing we'll need to do for the console lab after we sign in is we'll need to check if we actually have the stuff on our account that we need for this lab. I'll just wait like a few seconds. So if anyone has any questions or if they're stuck on something, just feel free to ask in the chat. And then I'll continue in like 5 seconds. Okay, cool. So we'll go under the, I believe it was the APN services, and then we'll go to library. And then we can search for dataproc. That's what we'll use. So I'll just enter dataproc, hit enter. Then I want to check the Cloud Dataproc API. And I'll see that this API is enabled. So that's all I need to do to make sure the API is enabled on this account. If for some reason on your account it isn't, just go back to step 1. You might not have logged in into the account that they provided. It might have logged you in automatically into like your own Google account or something like that. So just go back to the previous step, make sure you log in with the credentials that they gave you. Okay, so now that we know that Dataproc's installed, we'll go ahead and create a cluster. So that's a word that was talked about in the previous talk. So we'll actually see how to create a cluster here. So I think we come in here. Just give me 1 sec. Actually, yeah. So we'll go to the navigation menu and then Dataproc, which I believe will be under data. Yeah. So under big data, there should be Dataproc and then clusters. So again, that was, you just open up the navigation menu, you go down to big data, and then you go to Dataproc and clusters. So we'll create a data cluster here. So we'll just press the create cluster button. From here, if you're following along the quick start guide, they do have some defaults they want you to use. So for example, I don't think they matter, but I'm still going to use them just so that, who knows, things might break if you don't use them. So we'll go with by calling it an example cluster. And we can leave this as US Central 1. And I believe they ask you to switch this to US Central 1A. So I'll go ahead and do that. And then anything else you can leave as is. You don't have to change any other settings. And you can go ahead and click create. This will take a few seconds. So it's going to say provisioning. It's probably just spinning up some services to get this going. As you're following the quick start guide, there is a check my progress button. I'll just show it really quick here. So I'll show what I'm following along. So on here, they have these instructions. So as you follow along, there's buttons you can press to check your progress. So as you work through the lab and things are done, make sure you press the button to make sure it will actually check if you did the steps correctly, which is a good way to get feedback, I think. So we'll wait for, I think it just takes a few seconds. We'll wait for this to spin up. In the meantime, if you have any questions so far, feel free to ask them in the chat. I can help you out. After this is done, we'll actually run a sample job and sort of see how that flow works. Some of you might have a question like, what is this cluster? What's this useful for? So normally we have databases. I assume people that are tuned in are probably from CS or engineering, and if you're not, that's fine too. But normally we use databases for web apps or for something simple. But what if you have data that just simply doesn't fit into a computer, or even 2 or 3 computers, a crazy amount of data? Well, in that case, you need some sort of a distributed system where you can spread your data across many different computers, many different servers, maybe even across regions. And that's what these clusters are for. And tools like GCP actually make it really easy. As we saw, we just created a cluster in US Central, that's probably a region, with just a click of a button. And now we could put data, stream data into it, and then perform these quote unquote jobs. So let's see how what that looks like. So if I go into jobs here, I can submit a job. So job ID, it can be left as is. The region, we want the same region as our cluster, so I'm going to leave that as is. We'll actually pick our cluster here, so I'll pick the example cluster. We'll change the job type to Spark, and I wouldn't worry too much about this. This is just the actual technical implementation. You can look up what these different technologies are. And then we'll actually give it a path to sort of code or the script or the task that we want to run on this cluster. So if you're following along on that guide, again, I'll just bring this back for a second. If you're following along down here, you'll see what they want you to fill out. That's just that if you see me filling it out, it's not because it's not I've memorized these. I'm just looking through the same through the guide there. So we're gonna run this Java file, and this Java file is actually linked on the guide. It's on GitHub, so you can look at what this code does. Essentially, what it does is it runs a algorithm to estimate the value of pi. So we're going to be using this cluster, and we're going to be leveraging the fact that it can spawn workers and work on things in parallel to see how fast we can get the estimated value of pi done. So I'm just giving it the path for the actual code to run. And then in arguments, I'm going to put 1,000. So I'm telling it like run this 1,000 times, which is a large amount. So I think that's all. We can then go ahead and submit it, and we can see the computation happen live. I think what's really interesting to see here is just it does this all using RAM. So it's using 24 plus gigs of RAM. So you can imagine how this would not be feasible on like your computers. Like I feel like most people don't have 24 gigs of RAM on their computers. And this is for like what we're running is like very it's not actually that intensive. Like you can run some crazy jobs on here. So this is nothing. It's like hello world basically. But yeah, and it's like done really fast. Another thing we could do is let's say we wanted to change the configuration for our cluster. We could do that. I guess before I go to that, yeah, you can see the output from running that job in this console here. You can sort of see like what resources were being used and sort of like the performance and all that. Some good metrics. Let's say we wanted to change our cluster, so we wanted to update it. We could go back to the clusters tab. Over here, I believe we just click the cluster name. We can go over to configuration, I think. And then let's say we want to edit the number of worker nodes. So we want to increase the number of workers we have. So I can change this to 4. And then I can come back to the clusters tab. And this will take a second to update the cluster. Again, this is all happening with a click of a button. So I don't have to manage any configuration files and like update these things. Imagine trying to set this up yourself. It wouldn't be this simple. So thanks to GCP, this is really simple. Once this updates, we can try running the job again, and it'll probably run faster. I didn't get the timestamp on the last one, but I'm sure if we compared them, this one would run faster because it has more workers. Again, this will take a second to like update, and if we have any questions, I can. I'll just wait while this updates, and if there's any questions, I'll answer those questions. So I'll just take a look here. Okay, nothing's coming in so far, but that's fine. Yeah, so while this updates, it should just take a few seconds. Give it a few more seconds so that it's done, and then we can run the same job again, just to like make sure that it still works. Okay, so looks like it's done. So we'll go to jobs again. We'll submit another job. We will pick our example cluster. We'll pick Spark again. Over here, we'll do same thing. So we'll give it the path to this Spark Pi. Again, for anyone that just tuned in, this is just going to calculate, this is going to run an algorithm that calculates the value of pi, or estimates it rather. And we'll say run it 1,000 times again. We'll go ahead and submit it. Again, it'll take a second to spin up and run the algorithm 1,000 times. If we actually wanted to look at the well, actually, I'm not sure how I got to that, but yeah, I think in the so in this guide they do have a link to the like actual code that we're running if you're interested. But once you're at this stage, there is a small quiz that you can do to sort of wrap up this lab. I won't do this. I'll leave this up to you, so you can go through this again at your own time and then answer these questions down here to sort of finish this lab. I'll wait for a few seconds now to see if anyone has any questions. And yeah, before we jump to the next lab. Yeah, so once the 30-minute timer ends, you'll actually just lose access to this to this instance. Don't worry, just go back and start it again. Just be mindful of those tokens that you have. I think you can get them again, but someone might want to confirm that in the chat, maybe Saurabh or Sana. Yeah. Okay, so I guess we can proceed with the second lab, which is the console. So I'll just bring it up here for a second. So again, to navigate this, on the left we have, so we just finished the command line lab, and there's some videos you can watch. Sorry, we just finished the console lab. So there's some videos you can watch. There's some readings, associated readings with them. And then there's also the lab itself. So the next lab we'll look at will be the command line app, command line lab, sorry. But yeah, we'll go through this as well. So I can just close, since this was an incognito tab, and that's why I recommend opening them in incognito, I can just close this. But before you close it, do make sure that you check off the items, like you press the button that says, let's see. So as you go through them, make sure you do press the check my progress buttons. Yeah. And then once you're done, you can just hit end lab. And that should be good. So I'll just end this lab. It's nice. All right, so we'll head on to the lab on the command line. And again, I'll do sort of the same thing. So leave this here and then open up an incognito window. So I'll start my lab. I'll use my subscription. Okay, it will give us the link. So I'll just copy this link, throw it here. It might. Okay, so I'll grab the password. So just log in. There we go. I'll full screen this so it's easy to see. I'll accept the terms of services. I'll zoom in. Hopefully that's good to see. And I'll just open the other tab here. Go. Cool. Okay. So the command line is sort of a really important tool at GCP. It lets you, sort of gives you like a terminal to interact with GCP. That's one way you could think about it. It's more powerful in that it gives you it gives you like programmatic access to GCP. So you're not relying on just using the UI to do various things. Like you could spin up some services through the console, you could configure them, you could modify them, so on and so forth. Okay, so just give me one sec here. So after logging in and accepting the terms and conditions, we're going to activate the Cloud Shell. So that should just be through this button up here. We'll go ahead and activate the shell. Yep. Just hit continue, and that should open up this little terminal down here. We'll just give it a second. Okay, so those of you who are familiar with terminals, you'll see that this looks basically like any other terminal. So you could run some commands in here. So if you're, again, I'm following the the lab here. So there's commands here that I can run and then output and see what I want to do with it. So as I run through that, let's run a command to sort of get the active account name, because I think we'll need it pretty soon. So to do that, it's gcloud auth list, and that'll ask us for permissions, so I can give it permissions. There we go. And I need to, and I think I'll need this account name later on. So we'll just keep that here. After that, I need to get the project ID. So I'll do gcloud config list project. Yep. Okay, so I got the project ID. Now I need to make sure that before I continue, I need to make sure that I have permissions. And for permissions, they use this IAM and admin dashboard. You can imagine, like, if an organization is using GCP, they wouldn't want everyone to have access to everything. You'd obviously want to limit what people, or maybe like what services have access to only certain things. So they use this sort of identity management system to give permissions and things like that. So we'll try using it. So in here, if we go to IAM, and then let's scroll this down a little. So what we want to do here is we want to check if this if our account here has the editor role. So again, if we're following along on the guide here, we want to check if this account that looks like the project number -compute@developer.gserviceaccount.com is there, and that it has the editor role. So let's look at this account. So it should be, so if we look at the account up here, it should be something like some numbers followed by -compute@developer.gservice. Okay, it's present. For me, it's this account up here, and it does have the editor role. So I can proceed to the next part of the lab. So in the Google Cloud Console, on the navigation menu, so we want to click Home. Okay, so actually not sure where that wants me to go. Okay, just one sec. Oh, that's for if the account's not present. Okay, but I think in my case it is present. So if the account is not present for you, there are instructions to add an account that will have that permission. So you can run through those, and that will get you to have some practice with permissions and how permissions work. Okay, let's see. I'll just run through quickly as to what they're talking about so you can get a brief overview. So they want us to go back to home and then copy the project number, and then go back to IAM. So that was IAM right here. Then from here, we would go to add, and then I think we can just throw the project number here. Oh, so it's the project number dash, and then if you're following the guide here, I'll just bring it up one more time. So if you're following the guide here, so this is the member we want to add. It will be the project number dash this second part, which is the email. So it would be, I think it automatically comes up, but yeah, that would be the account that we'd want to add. And for the role, we'd want to give it the editor role. So, oh, actually, no. Over here, we'd want to select project, I believe. Anyways, you could play around with this. I didn't have to do it, but if you need to do it, or for the role, you'd select the project role or basic, according to the guide here. And then from there, you would pick editor and you'd click save, and that would give you the account that you need. And then you could go ahead and save it. So again, we need to create a cluster again. So, but this time we're going to do it through the console. And you'd find that this is normally how you'd be interacting with GCP. So if you're writing a program, if you're interacting with it through like Python or JavaScript or whatever, you'd have some sort of a GCP library you'd install, and then you'd do it programmatically, or you'd do it through the console. So the command to do that would be gcloud config set, and we want dataproc, and we want it to be in the US central one. So try running this and see what happens. Cool. This will create a cluster for us. So let's check out that it did. Let's go back to clusters, and it'll be down here in dataproc. Give it a second to refresh. Oh, I think we haven't actually provisioned it yet. So we'll go through and run the rest of the commands. Yeah, so we'll then do gcloud dataproc clusters. Yeah, this will actually start it. Create example cluster, and then we're gonna give it some some defaults. So worker boot disk size 500. You can look up their documentation to see like what each of these is doing individually. Actually, what I'm going to do is I'm going to run it like this to make sure I've copied it correctly. You could copy the commands directly from the guide itself. So again, these commands are on the lab guide. I'll go ahead and run this. This might ask you to confirm a zone. You can just press Y to do that. Let's see if it will ask me, but this will spin up a cluster for us, and it should give us a created message once it's done. Again, if you have any questions so far, feel free to let me know. If you're following along, or if you do this later on, once you're done this part, do make sure to hit check my progress, and it will check off if you've actually done the lab. That's how you can go through it and finish all of them and get those badges that we were talking about earlier. So once this is done, we'll also submit a job. But again, we're going to use the console this time, not the UI. So it will be cool to see. And there we go. Like it refreshed automatically, and we can see that we've provisioned the cluster again, but this time we did it through the console. Previously, we did it through the UI itself. And again, the differences being is this gives you finer control, and it lets you do things sort of like programmatically. Like the other version's designed for a human, but a computer could spin up a cluster by itself by using the console, for example. Or if you're just a person that likes working with consoles, this is for you. Okay. We'll wait for this to refresh. I think it will do that once it's ready. So once this provisioning status changes to running, there we go. Now this should, there we go. We got done. Awesome. next, we can run a job. So again, command's kind of big because we have to specify the files we want to run and give it like arguments. So I'm just going to go ahead and copy this instead of typing it out. So just press the symbol to copy the command. But do like look into the command. So let's see it before we run it. So I'll paste it in here. So again, it looks similar as the others. We're interacting with dataproc, giving it the cluster that we want to work on, and then providing the paths to the file that we want to run, and then giving that file some arguments. So again, running a file that will just sort of estimate the value of pi, and we're going to iterate it 1,000 times. So the more times you run it, the better accuracy you get. So just go ahead and hit enter to get this going. And we should start seeing this in the jobs once it goes through. So there we go. It's under the jobs. So previously when we ran this, the output was sort of shown in the, let me just make this smaller. The output was shown down here under the output window, but when you run it through console, you can actually get the output directly here. And I find that the console is actually slightly faster than the UI itself, which kind of makes sense as to why. But I think it's already done down here. Yeah, so it's already done down here. We see our output. And let's see up here. Yeah, so it might take a second to actually show up there. But that's how you would run a job. And yeah, once you're done that, make sure to hit the check my progress to make sure that you get the check mark for that and you can complete that lab. Another thing we're going to do, this is the last thing for this lab, is previously we tried updating the lab, but we did it through the UI. So this time we're going to try doing it through the console. I'll just go ahead and type clear. So you can type clear to clear out the terminal, and that's sort of the same command across many different terminals. So helps clear up the terminals if it gets really cluttered. To update the cluster, we're going to need the cluster name. So again, I'm going to copy this command from the guide, but we can see that this is updating this example cluster that we created. And we're going to set the number of workers to 4 because right now it's 2. So if we go back to the cluster, we'll see that currently there's only 2 workers. So you can go ahead and hit enter. Just going to quickly check the time I have left. Okay, we're good, 15 minutes. Yeah, like I said, these do only take about 10 or 15 minutes to do. So don't stress if you see the 30-minute timer. You have plenty of time to complete these. But yeah, this will programmatically update our cluster and change the number of workers to 4. Once this is done, we'll do the same thing. We'll try running the job again. Yeah, so again, this whole thing, what is this good for? So if you have a large data set that you want to work on, and by large, I mean it could be like terabytes of data. So obviously you can't really store that on your computer. So you could use something like GCP to put the data on there into a cluster. And then you could programmatically, like, let's say you want to analyze the data or you want to use it to train a model, or maybe you want to just clean the data up or whatever like you want to do. You could create a job and run it on that data. It'll be much faster than doing it on any other machine, for sure. So, okay, so we've updated the total number of workers to 4. Now let's try running the same job again. So get the command here. And again, we're running this on dataproc. It's a job, and we're submitting it to Spark on this example cluster. And we have our like Java files that we want to run, and we're giving it a variable, which is 1,000. So we'll run 1,000 times. This is just run our job and show us the output here. So again, I'll go back to the jobs window, and I can see that this job got queued and it's running right now. And I can see the output from the actual Java code in here in the terminal. as well as any other sort of output that's happening. You can get it here, which is really cool. Any questions so far?
I do just quickly want to mention we're almost approaching our time here. If you guys have any questions, feel free to head over to Kumo Space. I'll be hanging around there for a bit. Hamza can join for a bit too if you guys have any questions regarding this particular lab. But I highly encourage you guys to go and get yourself set up with getting your Google Cloud badges and finish them at your own pace. Oftentimes, personally, I find that watching labs like these hands-on workshop is very helpful. But to facilitate learning, it's I find that I learn best when I try doing it myself. And yeah, make sure you guys go in and get all the labs done, get your badges, and compete for the swag that we have. I want to quickly thank everyone. I want to quickly thank Hamza for being with us here today and going through the lab. You did a great job, Hamza. I want to quickly thank all the people that are working on the cloud campaign, Madusha and Daniel. Big thanks to you guys for making all of this happen as well. And thank you for Elizabeth as well for hosting this, helping host this event.
Not yet, but I will be after this. It's got me excited. Actually, the talk before got me really excited, so I'm excited to try it out.
Yeah, and I will also make sure I leave links on an email. Everyone that is attended here, I'll leave a link to the event page as well, so you can talk to Kalev and check out his blog, where he answers a lot of questions. And really interesting thing is it's all open source. Everything is used as open Google APIs, pretty much.
Yeah, I think so too, Madusha. I think we should build something live. That sounds fun.
Awesome. Madusha, did you have any final words that you wanted to say?
I don't think we can hear you.
Yeah, I think you might be on mute.
Obviously, it's not the most exciting topic when you talk about GCP, like you said, Saurabh. You got to get yourself into it, you gotta get into the rhythm. And it's even difficult to do it virtually, right? It's not, I think when we ran Cloud Study Jams in person, we saw a lot of these labs quests being completed. But you had some human interaction and it took about 4 hours. So don't get disheartened. And the initiative that we put together is not to complete quests overnight. It's for you to understand how to do it and understand and listening to other people, like what Kalev showed was pretty cool, right? Like and he's not a computer science major, or his focus is on journalism. So and that's why I always say the awareness part plays a big role. So now you're aware of what can be done, what can you go do with it, right? So I would like to encourage you all to find problems, maybe smaller ones. Maybe we all can come together and see how we can solve those. I like doing this since COVID started because I've been teaching myself, and I thought this is what we wanted to bring to the students. So good to see you all doing it. Make sure to promote, make sure to like, make sure to share. And encourage your fellow GDSC members to join and participate in this. So here's something that I'm working on, and I'm going to share this right now. We realized, yes, chapters are going to be displayed on the dashboard. Not every school from everywhere in the world is going to end up joining. So what we're going to do is we're going to do 2 streams. Number one, the North American chapters, whoever get the best accumulated badges, they'll get some items and some support outside of just us jumping on and helping you all with content. There might be swag, there might be some other items. And then we realized individuals who are joining in from all over the world. So we decided we would like to get you some one-on-one meetings with some Googlers, starting with me and Danny. Talk about your career, talk about what's going on, talk about what you want to learn. So anybody who within that week earns the most number of badges will get a one-on-one with me, and I'm volunteering Danny as well. And then we'll bring in other engineers who wants to participate in this. And you can talk for that half an hour. You can ask us any questions. get some advice as to how you want to plan your career, because we were students like you, and see where that goes, see where that conversation goes. So I think that's a really good incentive, we think, and it's easier to do. It's better than just sending you a t-shirt. I think it will hopefully have a lasting impression in what you want to do in your future. So that being said, back to you, Saurav.
Yeah, I think you guys should definitely try and getting that meeting with Madhusha and Danny. They're both amazing people, and they can guide you a lot. I know definitely leading this chapter at Carleton University has been a challenge. It's been new to everyone because it's the first time I've ever had it, and Madhusha has been there helping us throughout. Right, so definitely get your badges. I do also want to mention that there are events coming up next week as well. Make sure you tune into those if you want to pick up where you left off. So the next event will be on Monday. Let me just check what that date is. I think it's Monday the 25th. And they'll be picking up where they left off on the Cloud Computing Fundamentals lab that happened last Monday. Make sure you tune into those events. And again, these are self-paced labs. Don't feel any pressure to make sure you have to be there. Do them at your own time, right? That's how you learn, when you're relaxed and willing to learn, pretty much, not just being there for being there. But with that, I want to say thank you, and hope everyone has an awesome day.
The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.